Welcome to Pharmacology Insights, where we break down complex pharmacology into simple, easy-to-understand concepts. Imagine surviving a life-saving stem cell transplant, only to have it trigger a dangerous cascade of chain reactions in your smallest blood vessels. This is hematopoietic stem cell transplant-associated thrombotic microangiopathy, or TA-TMA. It is a rare, serious, and often life-threatening complication of stem cell transplant. In December 2025, the FDA approved Narsoplimab injection, marketed as YARTEMLEA, for the treatment of TA-TMA in patients 2 years of age and older. To understand how Narsoplimab works, we first need to understand what goes wrong in TA-TMA. During a stem cell transplant, the body is exposed to multiple sources of stress. Conditioning therapy, immunosuppressive medications, and infections all take a toll on the endothelium, the delicate inner lining of blood vessels. When endothelial cells are injured, the body interprets this as danger. One of the earliest systems to respond is the complement system, a key part of innate immunity. Most people associate complement with a terminal pathway, where C5 is cleaved, and the membrane attack complex forms to destroy cells. But TA-TMA is different. Here, damage is driven mainly by uncontrolled activation of the lectin pathway. The lectin pathway is activated when certain immune proteins act as sensors and attach to damaged or stressed cells. At the center of this pathway is a key enzyme, MASP2, short for non-binding, lectin-associated serine protease 2. MASP2 acts as an amplifier. When activated, it cleaves complement components C4 and C2, driving downstream complement activation. This amplifies inflammation, worsens endothelial dysfunction, and promotes platelet activation and microvascular thrombosis. In TA-TMA, MASP2 becomes pathologically overactive. This leads to the formation of tiny blood clots in the smallest blood vessel. Over time, this microvascular thrombosis leads to organ damage, most notably in the kidneys, but also affecting the cardiovascular system and gastrointestinal tract. This is where Narsoplimab comes in. It is a fully human monoclonal antibody, designed to selectively inhibit MASP2. Its mechanism is precise. Narsoplimab binds directly to MASP2. This halts lectin pathway activation at an early stage. By stopping the cascade at its source, Narsoplimab reduces downstream inflammation and thrombosis. Crucially, Narsoplimab does not block the classical or alternative complement pathways. Rather than shutting down complement entirely, it targets the pathway most responsible for the disease process. For patients with TA-TMA, who are already severely immunocompromised, this distinction is clinically meaningful. Preserving essential complement function helps maintain host defense while limiting pathological vascular injury. The FDA approval of Narsoplimab was based on results from the single-arm, open-label TA-TMA study, involving 28 patients. Patients received either weight-based Narsoplimab at 4 mg per kilogram, or a fixed dose of 370 mg, administered intravenously once weekly. Additional evidence came from an expanded access program that included 19 pediatric and adult patients. The primary endpoint was the TMA response, defined by improvement in laboratory markers, such as lactate dehydrogenase and platelet counts, along with recovery of organ function or elimination of transfusion requirements. In the main study, 61% of patients achieved a TA-TMA response. And in the expanded access program, responses rate were 67% in pediatric patients and 69% in adult patients. Let us summarize it all. TA-TMA is driven by endothelial injury and overactivation of lectin pathway. MASP2 sits at the heart of this process. Narsoplimab selectively inhibits MASP2, blocking pathological complement activation while preserving immune defense. This makes Narsoplimab not just another complement inhibitor, but a precision therapy. One that targets the mechanism that matters most in a devastating post-transplant complication. And in TA-TMA, precision can mean the difference between ongoing organ damage and recovery. And that's it for today's pharmacology video. If you enjoyed this video, please give it a thumbs up and subscribe to the channel for more pharmacology content.